Okay, we're going to be looking at sketching some somewhat complicated sine and cosine graphs, and usually we're talking about graphs here that have been quite heavily dilated and translated both vertically and horizontally. So the first thing we want to do is start with what we know. And so we've got to look at the question and first think, well, what's the domain? In this case, the domain is 0 to 2 pi. You can see the axis on the right here. That's why I don't have any negative x. So I know roughly what the shape will look like. And if I now have a look at the period, and I recognise here that there's an n, if n equals 2, then my period, 2 pi on 2, will just be pi. And so I can generally think, well, it's very likely here that there'll be quite a few x-intercepts. In fact, there'll be 4, because there's 2 periods within the domain of 0 to 2 pi, and there's 2 solutions per period. Now, looking at that, so far we've got quite a bit of the information we need, but like any graph, we need to find the x-intercepts, we need to find the y-intercepts, and also any critical points, any maximum or minimum points. Now, they're not always required, but I can show you a little way that we can look at those kind of towards the end of the video. First thing we might start with is the y-intercept. We can do this by letting x equal 0. So I know here that my y-intercept, just call it yi, is equal to 2 sine 2. I know that x is 0. And we've got negative pi on 3 minus root 3. Now, if we expand these brackets out, that's 2 sine negative 2 pi on 3 minus root 3. Now, finding sine of negative 2 pi on 3 is somewhat difficult. This is effectively looking at negative 120 degrees. So if we imagine our little unit circle, we think we're going in this direction 120 degrees. That means that we've got really the equivalent of pi plus pi on 3. If we imagine that we've gone 90 degrees here and another 30 degrees there, we know that on the inside is 60 degrees. And so really this is just like saying negative sine of pi on 3. Pi on 3. So really what I'm saying is this thing here, sine of negative 2 pi on 3, is the same as negative sine of pi on 3. And we know from our table of values that sine of pi on 3 is in fact negative root 3 on 2. So we know that that's in brackets. And we also know that we've got our y-intercept is 2 times that minus root 3. So if we now expand this out, the 2's will cancel. We have negative root 3 minus root 3. So our y-intercept here is equal to negative 2 root 3. We can label that on our graph down here. We know that that's 0, negative 2 root 3. Now, in order to find the x-intercepts, we're just going to let y equal 0. This can be quite a significantly more complicated problem. So if we started with 2 sine, we've got our x-intercept. In fact, that's 2 times this, my apologies, minus pi on 3 minus root 3 now equals 0. So I'm trying to find that x-intercept by letting y equal 0, which allows us to rearrange this to sine of 2, my x-intercept, minus pi on 3 is equal to root 3 on 2. Remember from when we were solving equations, we could imagine this complicated thing here is, let's just let a equal that, really anything. In this case, might even be more right to just let theta equal that. So if I had the equation sine theta equals root 3 on 2, well, again, we could just look at our table of exact values here, and we would know that the inverse sine of root 3 on 2 is equal to 60 degrees, or pi on 3. So I know that 2 times my x-intercept minus pi on 3 is just equal to pi on 3 being the base angle. And if we were to look at the complementary angle, pi minus pi on 3, we also have 2 pi on 3. Now, we may choose at this point, because we know there's going to be another 2 solutions. We can remember that from looking at our domain and our period. If I add 2 pi to this, or 6 pi on 3, I'll get 7 pi on 3, and my fourth solution will be 8 pi on 3. Now I'm just going to scroll down for a minute here. There we go. And all I need to do at this point is solve for the x-intercept. So I can see that I've got 2 times x-intercept minus pi on 3, so I might times each side by a half. And I'll end up with the fact that the x-intercept minus pi on 3 is now pi on 6. And really all these answers are valid provided they're over 6. 2 pi on 6, 7 pi on 6, 8 pi on 6. If I'm now adding pi on 3 to both sides, so I can see here that I can add pi on 3, then my x-intercept would be pi on 6 plus pi on 3, and 2 pi on 6, well 2 pi on 6 we can look at minimising now to being pi on 3, plus pi on 3. The 7 pi on 6 doesn't simplify, but we can add pi on 3. And the 8 pi on 6, well it's 4 pi on 3 if we simplify it. And we can add another pi on 3. Let's just fix that up. So now we're at the point where we'll have to simplify some of these answers. Pi on 3 can be thought of as 2 pi on 6. And so my first answer here is really 3 pi on 6. Oops, that's not what I meant to do. This answer here is what I meant to simplify as 3 pi on 6, which we know to be pi on 2. And our next answer, 1 pi on 3 plus another pi on 3 is 2 pi on 3. If I've got 7 pi on 6 plus 2 pi on 6, I'll have 9 pi on 6. Now this 9 pi on 6, we can simplify down to 3 pi on 2. And you'll notice here a little bit of a pattern. From the pi on 2 to the 3 pi on 2, we're just adding one of the periods, which earlier we worked out to be pi. So even without necessarily adding that last fraction, I may know that 2 pi on 3 plus a lot of pi is just going to be 5 pi on 3. Now the important thing here is to label these as intercepts. So I know here I've got my first pi on 2. I know here I've got 2 pi on 3. Then I've got 3 pi on 2. And my last thing being 5 pi on 3. And my general shape for a sine curve, I know that this is going to go up, it's going to likely go down again, it's going to come back up, it's going to go back down, and we'll have an endpoint at 2 pi. I have to forgive the shape of that sine graph there. It's not the best on the iPad, but do what we can. So it's really important that we're also labelling all critical points, and that includes this endpoint here at 2 pi. So thinking about that endpoint, well, that can be achieved by subbing in. The y part of that endpoint is 2 sine 2 times 2 pi minus 3. Sorry, minus pi on 3. And 2 pi minus pi on 3, if we think about that's just really a negative quadrant. But again, that 2 pi can be treated like 0, and we might realise that we've already done this. It's over here. So it's just a matter of repeating that point as we know it to be negative 2 root 3. Now the maximum points, well, we actually know something about this when we look at the amplitude. We know that the amplitude is 2. So this maximum point here, whatever the x value is, we know the y value is going to be the vertical translation plus that amplitude. So in this case, let's say we don't know what the x value is just yet, but the y value is going to be that vertical translation of negative root 3 plus 2. So we've got 2 plus negative root 3. So let's just fix that up so that it's 2 minus root 3. Again, here I don't know what the x point is going to be, but I know the y point will be 2 minus root 3. And down the bottom here, whatever the x value is going to be, the y value is now going to be negative root 3 minus another 2. So the question might be asked now, how do we get the x values? You may remember from quadratics that the midpoint of the two x-intercepts will always give us the maximum or the minimum. So in this case, we're looking for the midpoint of pi on 2, which is this one here, and 2 pi on 3. So we can achieve that by saying, apologies, we're running out of room here, but pi on 2 plus 2 pi on 3 divided by 2. Now we can say that this is the same as 3 pi on 6 plus 4 pi on 6. So we get 7 pi on 6 divided by 2, which we know to be 7 pi on 12. So this point here is 7 pi on 12. Well, the next critical point is always going to happen exactly one period away from this point here. So the maximum there is going to be 7 pi on 12 plus pi, or 7 pi on 12 plus 12 pi on 12. So we know that to be 19 pi on 12. Now a minimum point here, we actually can't see it, but I do happen to know that it's lower than negative 2 root 3, so we don't have a reference point. But we could think to ourselves, what's halfway between 2 pi on 3, so that's this point here, and 3 pi on 2? Well, halfway between those, and I'm just going to scroll down so that we're constantly running out of room here, but we're after the midpoint of 2 pi on 3 and 3 pi on 2, so we'll divide by 2. So this becomes 4 pi on 6, this becomes 9 pi on 6, so we end up with 13 pi on 6 divided by 2, which is 13 pi on 12. So we now know up here that we've got 13 pi on 12. So as a little bit of a summary, we can look at our graph here and we can see that we've got the y-intercept labelled. We've done quite a bit here, but the y-intercept here. Well, we achieve that by letting x equal 0. We've got our x-intercepts, which we actually achieved by allowing, so I just changed colour, my apologies, we've got our x-intercepts here, which we achieved by letting y equal 0. We've got our endpoint, which in this case was going to be the same as the y-intercept. And our maximum minimum we found by getting the midpoint of the first two x-intercepts. Our last step, of course, is just to label the graph. So we need to label this as y equals 2 sine 2 x minus pi on 3 minus root 3. Now I'm going to try and leave a little bit more room here, but if we have a look at, again, starting with what we know, we can look at the domain being 0 to 2 pi. So the axes that I'll need are not going to be any negatives. So there's my horizontal axis. Just set up my ruler here, and we'll get our vertical. We can label this y and x, as it is in the question. And the next thing we want to have a look at is our period. Now if n is equal to 2, our period is equal to 2 pi on 2, which is just pi. So again, in this situation, we're very likely going to see 4 solutions for x. If I think about the vertical translation there, so I can highlight that to make it a bit clearer. Vertical translation of -1, and our amplitude of 2 means that we're certainly going to have x-intercepts, because we've got a maximum of 1, a y value of 1, and a minimum y value of -1 minus 2, which is -3. So it might be worth at this point also labelling that our max is equal to 1 and our min is equal to -3. Now remembering again that to find the y-intercept, we're just going to let x equal 0. So the y-int is equal to 2 cos 2, 0 minus pi on 4 minus 1. Now one thing to remember here is that we've got 2 cos, now this is negative, so 2 times that negative pi on 4, it's going to be negative pi on 2. This is already a little bit easier because we know that cos of pi on 2 or negative pi on 2, same thing, it's going to be 0. So we can scrap that, and we know that our y-int is 0, 1. So we can place that here now. You might also recognise this as the maximum value. So we've already got one turning point, which is going to make things a lot easier. So the next thing here is to find the x-intercepts, our next major critical point, and we know that we can do that by letting y equal 0. So if I had 2 cos 2, remember I'm finding now my x-intercept, which is different to x, minus pi on 4, minus 1 equals 0. So really I'm after, where does cos of 2 x-intercept minus pi on 4 equal 1/2. So again, I'm going to consult my table of exact values, and I know that the inverse cosine of 1/2 is pi on 3. It's our base angle. So I now have the case that 2 x minus pi on 4. Now, I'm going to leave that in purple here because you can remember I might as well think of that like making a substitution, or really just treat it like it was in a theta or one big X. And I know that the base angle, as we mentioned from the table of values, is pi on 3. Now that means our corresponding angle is 2 pi minus pi on 3. So that's that angle that would take us down to the fourth quadrant. So 2 pi being 6 pi on 3 minus 1 pi on 3 is 5 pi on 3. We said before by analysing the domain and the period that there's going to be 4 intercepts. So I might as well start by adding 2 pi. So pi on 3 plus 2 pi is 7 pi on 3, and 5 pi on 3 plus 2 pi is 11 pi on 3. Our next step here will be to divide everything by 2. So I've got the x-intercept minus pi on 4, or the x-intercepts rather, are equal to this pi on 3 will become pi on 6. This 5 pi on 3 becomes 5 pi on 6. 7 pi on 3 becomes 7 pi on 6 again. And the 11 pi on 3 is now 11 pi on 6. If I add pi on 4 to all these answers, then we can have a look at this and say, well, pi on 6 plus pi on 4. Well, we might have to get a common denominator here. And let's just choose 12. So I've got 2 pi on 12 plus 3 pi on 12. Now 5 pi on 6 plus pi on 4 is 10 pi on 12 plus 3 pi on 12. 7 pi becomes 14 pi on 12 plus 3 pi on 12. We realise this 11 pi on 6, if I was to add something to it, it's bigger than pi on 6, it's going to take it outside the domain. So I'm actually not interested in the last one right now. We can evaluate this first one to be 5 pi on 12. We've got our next one here as 10 pi plus 3 pi, so that's 13 pi on 12. And our last one is 17 pi on 12. Now you might be thinking, well, hold on, you did tell us here that there would be 4 solutions, and you're in fact correct. We actually have to think back to the solution that would be first. Because we've translated to the right, we actually needed one of the negative base solutions. So if I think all the way back, and this is where it takes some level of practice and skill, if I think back to this 5 pi on 3, and if I subtracted 2 pi, I'd actually get negative pi on 3 as an answer. So if I'm thinking here that I also had the answer of negative pi on 3, then we divided that by 2, I'd have negative pi on 6. And then if we added that pi on 4, so that would be negative 2 pi on 12 plus 3 pi on 12, we get our first answer, which is in fact pi on 12. So here I've got pi on 12. I know that I'm going to go down, come back up. My next answer is 5 pi on 12. And following that, we've got 13 pi on 12. And we've got 17 pi on 12. We can think of 2 pi as being the same as 0. So I actually know that my endpoint here is going to be 2 pi comma 1. Now I've actually just realised that in fact I've made a mistake here. My y-intercept is not positive 1, it's negative 1. And I can see this here where I just made a transposition error. So in fact we need to change our graph ever so slightly. This is incorrect. We actually have 0, negative 1, and that means that my endpoint here will be 2 pi negative 1. So I'm just going to get rid of that mistake there. Okay, now that fixes up our shape a little bit. So we know that our shape is going to come up, it's going to drop back down, go down to a minimum here, come back up and drop back down. We know that our maximum points, as we mentioned, are going to occur at 1. So whatever my x value is here, my maximum point is going to be 1. And again, whatever my x value, my maximum point will be 1. I know down the bottom here, my minimum point was -3. So whatever my x value, I've got -3. Now, I can have a look at this and say, well, my midpoint between pi on 12 and 5 pi on 12, if I add those up together, I get pi on 2. Midpoint, we add them together and divide by 2, so we get pi on 4. This is pi on 4. Now, were I to add 1 period to that, in order to get its corresponding maximum, we end up with 5 pi on 4. Period being pi, or 4 pi on 4. Now the minimum value here is also going to be the midpoint between 5 pi on 12 and 13 pi on 12. So if I add 5 pi on 12 and 13 pi on 12, I get 18 pi on 12. If I divide by 2, that becomes 18 pi on 24, which we recognise 6 as a common factor, and this is going to be 3 pi on 4. Our last step is to label our equation. So our equation being y equals 2 cos 2 x minus pi on 4 minus 1.